Now what we're going to be doing is we're going to have both of the formulas, and we have to decide which formula and what we're solving for. So for example one, it says a person invests 15,000 in a mutual fund at a rate of 10.5% compounded quarterly. So the compounded quarterly tells us which formula we're going to use. We're going to use our first formula because compounded quarterly means that we're going to plug a value in for N. How long did she have the money invested for? How long means that we're solving for the time. So when we set it up, what we're going to do is we're going to go 50,000 is equal to 15,000. And then what we have is 1 plus, remember to turn the rate into a decimal, 0.105. And we're dividing that by 4 because it's quarterly, 4t. We're going to divide the 50,000 by 15,000. I'm going to keep it as a fraction just to make sure I have an exact answer. So that would be 10 thirds is equal to. Then what I'm going to do is I'm going to calculate my base number. And remember, I keep the exact on my calculator. I'm just going to write the rounded right here and then raise to the 4t. Now remember, when we're solving for our exponent, what we need to do is we need to get rid of our base number. So in order to get rid of our base number, we're going to do the log of that base. So we're doing the log of 1.03, log of 1.03. This becomes 1. So what we get is the 4t by itself. I'm going to do the change of base formula. So I'm going to do the log of 10 thirds divided by the log of 1.03. Now, just as a reminder, I'm using the exact value, not the rounded value. So what I get is 46.465. Then I'm going to divide each side by 4. And that gives me t is equal to 11.62. Now, because it's compounded quarterly, this is not a quarter. So what we need to do is we always need to round it up in order to get that amount. So if we're rounding up quarterly, the next quarter would be 11.75. And that right there would be our answer. Now, for example 2, it says, what is the rate if 3,000 is invested and earns 1,000 in interest after 4 years? So far we know that we're solving for our rate, and it tells us that it's compounded continuously. So we're using our second formula. Since it earns 1,000 in interest, that means the total amount is going to be 4,000. So we have 4,000 equals 3,000. We're using the continuous formula. So E, we're solving for our R, and this is for 4 years. Once again, I'm going to divide by 3,000, and that gives me 4 over 3. I'm going to write down my exact answer. And what I need to do is I need to get rid of the E. So in order to get rid of the E, what I'm going to do is I'm going to do the natural log on both sides because natural log is base E, so that becomes 1. So 4R is equal to natural log of 4 thirds gives me 0.288. And when I divide that by 4, what I get is 7.19%. Now, looking at example 3, it says how long would it take 1,000 to become 6,000? It tells us the rate. Once again, it tells us how long, so we know we're solving for time. And compounded continuously means we're using our continuous formula. So we have 6,000 is equal to 1,000. E is the continuous. We have 0.0625. We turn it into a decimal, and we're solving for t. Once again, I'm going to divide by my initial value, which is 1,000, and that gives me 6. And my next goal is to get rid of my base number, which in this case is an E. So in order to get rid of it, what I'm going to do is I'm going to use the natural log. Natural log of E gives me 1, so I have 0.0625 t is equal to the natural log of 6. The natural log of 6 is 1.79. Once again, that's rounded. I'm going to use my exact answer when I divide it. And so I'm going to divide it by 0.0625. And that right there gives me an answer of 28.67. Now, notice that in this case, I'm not rounding it to the nearest quarter because it's continuous. So continuous means any of the answers. So I'm just going to keep that answer because that would be 1 day or 1 hour in the total of years. So continuous means that it's always happening. So we just take our time, whatever it is. For example, 4, it says, at what rate would, so once again, when we're looking at this, the rate we're solving for, we have our initial value, it doubles, 7 years is our time, it compounds monthly. So we're going to use our first formula. If it doubles, then that means 10,000 becomes 20,000. We have 1 plus, our goal is to find the rate, it's compounded monthly. And remember, the n also goes as our exponent, and we're timesing it by 7. Again, we're going to divide it by our initial value, which is 10,000. So 2 equals 1 plus r over 12. 12 times 7 is 84. Now, in this case, we're not going to be using a log. What we're going to do is we're going to use a root. So I'm going to take the 84th root. Now, just in case you forgot, if we don't know where the 84th root is, what you can do is go 2, and then we raise it to the 1 divided by 84. And that's going to give us the exact same answer as root. So we have 1 plus r over 12 is equal to the 84th root of 2 gives us 1.008. Now, once again, just as a reminder, I'm using my exact answer, not the rounded answer. First thing that I'm going to do is I'm going to subtract the 1. And then the second thing I'm going to do is I'm going to times it by 12. And I'm going to do those 2 steps on my calculator, subtract the 1, times it by 12. And that gives me a rate of 9.94%.